Tomorrow at College Street Elementary, and we're going to be talking today about using thinking patterns to multiply and divide. There are two thinking patterns that we use for thinking about multiplication and division. One is equal groups put together, or EGPT. The other is equal groups take apart, or EGTA. Now, just like we talked about in our addition and subtraction video, when we are using thinking patterns, the thinking patterns will stay the same whether you're in 2nd, 3rd, 4th, or 5th grade, even in algebra. It's the numbers that change. So in 2nd grade, you're mostly doing multiplication with one-digit numbers and skip counting. In 3rd grade, you're doing one-digit times one-digit numbers, or maybe even one-digit times two-digit numbers. In 4th grade, you might be doing two-digit numbers times two-digit numbers and decimals. And then 5th graders through 8th graders, you guys get the whole gamut. You get whole numbers, decimals, fractions, integers, or rational numbers. These thinking patterns even work when you get into algebra. This is a way for you to use the right side of your brain to explain the patterns we see going on in math, which is left brain oriented. First, let's talk about equal groups put together. Let's hope that our video loads.
I have equal groups put together.
Okay. So an equal groups put together picture is going to look something like this. With equal groups put together, you are missing the total or the whole. Now for my example, I have 7 parts in my picture, but you might have a different number of parts depending on the problem that you are solving. Let's look at this as an example. The baker arranged a display of blank cupcakes on each of his blank shelves in the display case. How many cupcakes did the baker display? So in my picture, I know that I'm going to have a number of cupcakes inside each shelf. And how many shelves I depend on whatever number I put in that blank. So in this picture, I have 7 shelves. You might have a different number of shelves in the problem you make up, and that would change what your picture looks like. So then I would solve this by doing how many cupcakes times how many shelves equals the total number of cupcakes. So the part that's highlighted is the part that I'm looking for. Let's look at equal groups take apart. Give it a second for the video to load. Sometimes it loads right away. Sometimes it takes a few seconds. Let's see. Awkward silence filled in here. Here we go.
I have equal groups take apart.
Okay. So in equal groups take apart, we have the same picture that we had before, but this time we're missing the parts of the picture and we know the total. That looks different, so let's look at what that could look like. The baker arranged a display of blank cupcakes in the display case. On each of his blank shelves, he put an equal number of cupcakes. How many cupcakes did the baker display on each shelf? Now you'll notice that our picture looks exactly the same as the part-whole picture we had before, except this time we're missing the number of cupcakes that go on each shelf, so a different part of the picture is highlighted. Now again, for my picture, I have 7 different parts. You don't have to have 7 parts. That's just how I made this picture. You might have 6 shelves, or 18 shelves, or 120 shelves if it's a giant bakery. I don't know. So you can make the picture match the number you choose to use in the blank. You might also have a equal groups take apart problem where you don't know how many parts you need. Let's see what that would look like. The baker arranged a display of blank cupcakes in the display shelf. He put cupcakes on each shelf. How many shelves did the baker need to use for his display? So in this case, we do know the total number of cupcakes And we know how many cupcakes are going to go on each shelf. So we're trying to figure out how many shelves would we need to draw. So you would have to fill those in as you go. You can practice this by putting in the numbers of your choice that you would like to use to make this problem make sense and fill in those blanks with actual numbers. You will use the same organizing pattern that we use, organizing system that we use when we're doing addition and subtraction problems. So at our school, we analyze the problem by asking what's important, what's the question asking. That's the part that you're looking for that's yellow that we've highlighted in our examples. And the part that most kids skip is planning the problem. Kids want to go straight from reading the problem to solving the problem, and that's why sometimes you add when you're supposed to subtract. I've done that before, have you? Or maybe you multiplied and it was supposed to be a division problem. So we want to spend time on the plan. You want to think about what's going on and act it out with your thinking pattern. What kind of story is it? Is it some and some more, some went away, bigger, smaller difference, equal groups put together, or equal groups take apart? What would your number strip picture look like for that problem? Every problem can have a number strip drawn for it. And then you need to figure out, is that a one-step or two-step problem? A lot of the times I work with a lot of 3rd, 4th, and 5th graders. The most common mistake they make is they only did one step and it was supposed to be a two-step problem. Let's look at some two-step problems. Now, these problems can be solved using more than one step, and often they can be solved more than one way and still get the correct answer. That means that you could solve it one way and somebody else could solve it the other way, and you both could still get to the right answer, which makes for a really interesting conversation when that happens. So first we're going to do an equal groups put together and then an equal groups put together again. Let's see what that would look like. Kieran's mom bought packs of pencils that have pencils in each pack for each of Kieran's teachers. How many pencils did she buy? There's a lot going on in this problem. So first, you would know how many pencils are in one of those tiny, tiny boxes. And then you would have to know how many packs of pencils. Now, I did 3 packs of pencils because I have 3 spaces for those pencils to go. That would tell me how many pencils for each teacher. If you're not going to use the number 3 for Kieran's mom bought packs of pencils, you would have to have a different picture drawn for yours. Then that would be the number of pencils for each teacher. Now for my picture, you'll notice that I have a space for 4 teachers. So you might have more than that many teachers on your problem. And then that would help me figure out the number of pencils total. You could do equal groups put together and then equal groups take apart. For example, the 3rd grade teachers are ordering supplies for Glow Math Night to share equally among the classrooms. They ordered packages of Glow bracelets. How many Glow bracelets will each classroom get? So in our first step, you'll notice that we're looking for the number of packages times the number of Glow bracelets. So I know how many Glow bracelets go in each pack. Now, because I had done this picture in advance, you'll notice I have 5 spaces. There might not be 5 packages. Maybe you picked a number different from 5. So you would have to change your picture to match the number of your packages that you picked. And then we would multiply that to get the total number of Glow bracelets. That's our first yellow part. That's per class. That's all of the total Glow bracelets. So notice that comes over here. That doesn't tell us per class. That was the total number for the whole 3rd grade. So we're going to move that total number over and then divide it per each of the classes. Now we happen to have 7 classrooms at our school, so I divided it into 7 boxes, but you don't have to use the number 7. You could use a different number depending on what your school looks like and how many 3rd grade classes or 4th grade or 5th grade classes you have at your school. But you're welcome to put in your own numbers and draw your own picture to make this problem make sense. Anyway, I hope that these videos were instructional for you. I'm going to link to some problems with multiplication division that you can solve on your own and practice with your thinking patterns and your part, whole pictures to help them make sense to you. Have a great day.